This video is just another example of the Rolle's theorem problems. And so again, we're asked to determine whether or not Rolle's theorem can be applied. If so, find all the values of C that make it true. And so we had to go back and revisit what Rolle's theorem was, and it told us that as long as the function is continuous on a closed interval AB, differentiable on an open interval AB, and the two y values of the endpoints are the same, then somewhere in AB, the derivative is 0. And we'll kind of take a look at the implications of that later on too, as far as what does that mean for extrema. All right, but here's another example. And so we have to check the three things. So 1, is F continuous on -1, 3? Okay, and now I keep referencing this, and eventually I'll go look it up, and maybe I'll do a short video on it, but by and large, if the two functions that make up a rational polynomial or a rational function are continuous, then the rational function is continuous, so long as the bottom is not 0. And here we have issues when the bottom is 0. So as long as x is not -2, so we have problems at x equals -2. Now, if you look at this, though, is f continuous on -1, 3? Well, yeah, that's fine. Yeah, it's continuous because we'll just get a fraction. As long as that fraction is not divisible by, or it does not have a 0 in the denominator, then we're fine. And since -2 is the only point where it does, then we're okay. So yes, because -2 is not part of our closed interval. Is f differentiable on the open interval -1, 3? Open interval. And now you can take a look at this again, and you can kind of divine this and say sure, but I like to do it this way. If it is differentiable, you're going to have to take the derivative anyway. Just go ahead and take the derivative. It's fine. And so let's take the derivative of f. It is the derivative of the top, 2x minus 2, times the bottom, x plus 2, minus the derivative of the bottom, which is 1, times the top, x squared minus 2x minus 3, all divided by the bottom squared, x plus 2 squared. Okay, so now, is it differentiable everywhere? Well, we only have problems. We don't have any absolute values, so that's okay. Okay, we don't have any jumps, massive jumps. What we do have, though, is we have a problem here when this is equal to 0. So when x plus 2 quantity squared equals 0, we have a problem, which means that x is equal to -2 again. Well, this is not in -1, 3, the open interval, so we don't have to consider it. So now if we look at it, then yes, it is. So we can answer that with a resounding yes. Yes. The third thing that we have to look at is we have to look at whether or not the y values are the same. So number 3, does f of -1 equal f of 3? Well, let's find out. F of -1 is equal to, if we look at the original problem, okay, let's keep that up there. So we have -1 squared minus 2 times -1 minus 3 all over -1 plus 2. This is 1 plus 2 minus 3 all over 1, which is 0 over 1, which is 0. Okay, now let's check the same thing for f of 3. F of 3 is equal to 3 squared minus 2 times 3 minus 3 all over 3 plus 2. This is 9 minus 6 minus 3 all over 5, which is 0 over 5, which is 0. So yes, it does. All right, first question. Determine whether or not Rolle's theorem can be applied. It is continuous on the closed interval, it is differentiable on the open interval, and the y values of the endpoints are the same. Now we can go ahead with it. So that means, so all this, okay, all of that stuff implies that then there is a value x equals c. Apparently my c's are just having a rough time of it today. C such that, and that little sign just means such that, okay, such that the f prime of c is equal to 0. All right, well, we already found the derivative, so we set the derivative equal to 0, and we find all values that make it true. There's our derivative. Now that we have that, we can just copy it. And so what I can do is I can just do this. Now I can go copy. Come down here, paste. Move that right up here. See, isn't that handy? Okay. So we know we have to set the derivative equal to 0. Our derivative, if we kind of do this out and simplify it a bit, is negative or 2x squared, and this is plus 4x minus 2x minus 4 minus, and now we take this and distribute that negative 1, minus x squared plus 2x plus 3 all over x plus 2 quantity squared. Now, looks nasty. Remember, we're looking for where it's 0. The bottom can never make it 0. In other words, we want to know when 0 equals the top. Okay, so we have x squared, and that takes care of my 2x squared and my negative x squared. 4x plus 2x is 6x minus 2x is 4x, so we have plus 4x all together, and then we have negative 4 and 3 is negative 1. Okay, so all of that, that's all we really care about. Now let's go ahead and solve that. Again, you could solve this by completing the square, and I think I'm going to do that this time. To complete the square, so complete the square. To do that, we're going to need to take half of the central term, half of b. Okay, so take that and take half of that, which is 2, square it, which is 4. That's what we want this number to be. So we have 0 is equal to, or better yet, we need that to be 4, so let's add 5 to both sides. Plus 5, plus 5. So we have 5 is equal to x squared plus 4x plus 4. Okay, that means that 5 is equal to x plus 2 squared, quantity squared. Which means that x plus 2 is equal to plus or minus the root of 5, which gives us x is equal to negative 2 plus or minus root 5. Yeah, that wasn't so bad. Okay, now that we're done playing around with that, we can go back and check it. So we have 2 of them really. We have x is equal to negative 2 minus the square root of 5, or, I should say and or, because they could both be okay. And, or, x is equal to negative 2 plus the square root of 5. Now this first one, we have negative 2 minus root 5. That's going to be, x is going to be less than negative 2. Okay, that means that it's not in our, this is not in negative 1, 3. So we don't have to consider that. The other one, however, this is going to be just greater than 0 because 5 is a little bit bigger than 2, or root 5 is a little bit bigger than 2. So x is going to be greater than 0. but it's going to be less than 1. So let's do it this way. Okay, so 0 is less than x is less than 1. It's going to be somewhere around 0.25. All right, so now it says find all values. So the second half is, if it's true, find all values of c that make it true. Here we are. This is it. That's the only one right here. True. So our answer for this is simply going to be, let c equal -2 plus root 5. Done. All right, in the next video, let's take a look at one that doesn't work.